Thank you. It's a pleasure to be here to talk to you this afternoon. Yes, my interest in astronomy and space-related matters and trying to understand how the universe works actually predates my time as a physicist. Eventually, I became a physicist, but I think I've been interested in the stars and space and the universe since I was younger than you are here. So this is a short talk about robots on Mars because Mars is visiting the cathedral in Peel. It's only a short talk. I'm happy to take questions afterwards, and I'm happy if you want to come down and take a closer look at this glorious orrery of the solar system sitting on the front table here. So let's kick off. What I'm talking about is a very short introduction to Mars and Martians, and then listing some of the landers and rovers that have been to Mars. I'm not going to give you a comprehensive set, but I'll pick a few out. And I'll be asking what have they found, and to finish, what's next? We know there are a few rovers on Mars. What's the next plan? So man has always had a fascination with Mars and Martians for, well, you could argue for millennia, but certainly for hundreds of years. It dates back to, well, for those of us of a certain generation, it dates back to the original H.G. Wells novel, War of the Worlds, the radio, the film, or perhaps for the slightly younger generation, the musical. Okay, a little bit more lightweight, but still a fantastic record if you've never actually listened to it. But of course, to many people, if you say Martian, you don't necessarily think of War of the Worlds. For many people, if you say Martian, they think of Matt Damon, because that's the Martian that they perhaps know and love. But we should just take a second to remind ourselves how amazing this is. 100,000 years ago, some humans were still living in caves. And yet it is now possible to build machines, put them on the top of a rocket, send the rocket to another planet, land that machine, and have that machine trundle around the surface of the planet, returning high-resolution images like this. The fact that we can do that is absolutely amazing. The technology has come an awful long way just in the last few decades. One of the reasons for going to Mars is, well, it's interesting geology and it might be interesting climate, but mostly we are asking the question, is there life? Was there life? Has there ever been life? Because that is often a driving force to our desire to explore the solar system. It's not the be-all and end-all of everything, but it often captures people's imagination to ask, is it possible that there were Martians at some point? And that's why we always have this fascination. We look at the surface of Mars, it's arid and dry and doesn't appear to contain any water. But there is quite definitely evidence that water has flowed on Mars. And talking of water, it looks like my water has just arrived. Excellent, thank you very much. So we know there's evidence that there have been lakes and rivers and rain. It looks very dry and arid now, but if it's had a history which has included water, then it's always possible that life has evolved there. So I'm not going to go through all of the landers and rovers that have ever been to Mars. I'm going to concentrate on the American ones simply because there's more information about the American ones than there is for instance, a Chinese rover, which is also trundling around on the surface of Mars. One of the very early landers was called Viking from the 1970s. Since then, there have been various combinations of landers and rovers. Spirit and Opportunity in the early noughties, landing in 2004. And then there have been other landers and rovers. Curiosity and Perseverance are the most recent. They are very similar rovers. And so I'm not going to talk about each of these. I'm just going to pick out a few highlighted in red that, in a sense, tells the story of how we've been exploring Mars. So for me, the story starts in 1976, when Viking went to Mars. No, we didn't send Carl Sagan with it. This is Carl Sagan up against a mock-up. Just gives you an idea of the scale of a lander, the size of a small car. Landers are easier to make than rovers because once they land, they just stay put. You might look around, you might dig a little bit of soil if you can reach it with your robot arm, but they don't have any wheels and move around. So they're easier and cheaper to construct. So no surprise, the first exploration of Mars was landers. But I was still absolutely amazed when the first images came back. Yes, I was impressed to see men walking on the moon, but I was almost equally impressed to look at color images from another planet. The fact that we could do that, send a lander in the 1970s, in the mid-70s, and I remember that TV image coming onto the color TV, look, this is the surface of Mars, in essence, live from the surface of another planet. I thought that was absolutely amazing. To get to Mars, actually, you don't need a very big rocket. You actually need a relatively small rocket to get to Mars, compared to the absolutely huge rocket you need to get to the moon. The Saturn V rocket is enormous. It's 3,000 tons. But the moon is closer than Mars, so why is it that it's easier to get to Mars, apparently in a relatively small rocket, compared to getting to our immediate neighbor? It's not about distance. It doesn't matter that the moon is actually closer than Mars. What matters is how many tons are you trying to get off the surface of the Earth and get into space and effectively allow it to reach escape velocity so that you can then fly off wherever it is you want to fly off. In the case of a Saturn V, that was designed to lift more than 100 tons from the surface of the Earth into orbit. For a Mars rover, well, a Mars rover might only be a ton or two, and therefore lifting it off the surface of the Earth and sending it on its way to Mars is an easier effort. The distance is irrelevant, it just takes longer to get there. The size of the rocket is determined by how much mass you want to lift off the surface of the Earth. What do we do when we get there? Let's have a look at what Opportunity did in 2004. When it arrives at Mars, it's got to slow down. It uses the Martian atmosphere. The Martian atmosphere is very thin, but it can still slow down the spacecraft as it enters. Eventually, it's going slow enough that it can actually deploy a parachute, a huge parachute, a supersonic parachute, because it's still going really fast at this point. How do you test anything that size? Difficult. But once it's slowed down, they can remove the heat shield, and the rover is in that little pyramid there. How do we actually get it onto the ground? What's the easiest way to do that? Rockets are rather tricky. The easiest way of getting that particular rover on the ground? Airbags. You don't worry about having a really soft landing. You get close to the surface, and you have little retrojets to slow you down. But once you're within 10 or 20 meters of the surface, you just let it go, and you let it bounce, and you let it bounce, and you let it bounce. You obviously have to make sure that when you package up your rover inside this little pyramid inside there, you've obviously got to make sure it's all secure. You've got to test it to make sure it can take the G-forces that it's going to get when it does this. 28 bounces later, Opportunity finally came to rest, and then they realized they could deflate the airbags, and then you can get your rover out. It's a very neat trick that it unfurls itself and also makes sure that it's the right way up. When this pyramid opens up, it guarantees that the little rover inside is the right way up. So there's the little rover packaged within the little pyramid. One of the first things it needs to do is to get power. And that means, in this particular case, solar panels. So solar panels will unfurl here, like a rather dainty butterfly, to open up to the sun so it can start powering its batteries. In the middle is a little mast with a camera, and that will then unfurl and go into the vertical position. So there's a stereo camera. Just behind that, it looks a little bit like a table tennis bat. That's actually a little aerial that is used to communicate with the orbiter, which ultimately will then relay messages back to Earth. So with its stereo camera on the top there, it can look around and get the gist of, yes, I definitely am the right way up. It can tell Mission Control it's okay. And then Mission Control on Earth can say, right, get your wheels sorted out and start moving. So at that point, it will then deploy its wheels. They're tucked underneath it for travel, but now it'll open them out. Most rovers have 6 wheels to make sure that if one goes wrong, it can still move around on the Martian surface. It'll need to double check where it is and what rocks are immediately in front of it. So again, the stereo camera will double check that it's going to be going in the right direction, and it will decide whether or not it can trundle over a rock, or whether the best thing to do is, well, maybe we should stop and go round it. So maybe we do a little bit of a maneuver to go round this rock. And then it's off on its travels to explore Mars. Spirit and Opportunity, which were effectively duplicate rovers sent to different parts of Mars because we want to explore different parts of the Martian geology, they had a predicted life of about 90 days. So in other words, they were designed to explore Mars for 3 months. Anything beyond that was just a bonus. The engineers who make these things try and make to a particular specification, and in a sense they said, we are sure it's going to operate for 3 months. With a bit of luck, it might operate a bit more. In fact, Opportunity explored Mars for 14 years, despite the fact that it was actually designed to work for 3 months. What is it that ultimately stops a rover working? In principle, it might be that if you've got solar panels, maybe you've got power forever. But that's not quite the case, because if you were to take a selfie by taking the camera and looking directly down, you can see there the solar panels. There's the Martian surface in the background with various tire tracks because it's been maneuvering itself backwards and forwards. When you first get to Mars, the solar panels will probably look quite clean. But the dust, the sand and the dust of Mars, very fine, and although there's not a great pressure in the Martian atmosphere, that dust can be picked up and distributed over the whole planet. So occasionally you get a lot of dust in the atmosphere. And if you look at what this looks like a few months later, well, there's an awful lot of dust on those solar panels. So much you can barely see the difference between the solar panels themselves and the Martian surface in the background. So no surprise, these solar panels are not very efficient. You might say, why didn't they just have a little robot brush to brush the sand and the dust off the solar panels? Well, it's a bit like volcanic ash. It's very gritty and very sharp. If you try and scrape this off, all you'll do is scratch all of the solar panels, which again will reduce their efficiency. So sometimes it is literally the amount of dust on the solar panels that might dictate the life of a rover. Sometimes they were lucky. Along came a little dust devil and swept the solar panels clean and gave the rover a bit more life. In terms of why you absolutely need to keep the power going all the time, if we remind ourselves about the tilt of Mars's axis, very similar to the tilt of the Earth, roughly 25 degrees, and the length of time they take to spin once, very similar as well. Earth spins once in just under 24 hours, Mars spins in a little over 24 hours. So with a similar tilt and a similar day-night cycle, the tilt will dictate the summer-winter seasons. So even though they are different distances from the sun, they have similar diurnal cycles and similar seasonal cycles. Unlike the Earth, though, Mars doesn't have a thick atmosphere. Our Earth atmosphere effectively acts like a nice duvet and keeps us warm at night. So we get a lot of solar radiation during the day, but the nighttime temperatures, yes, they can drop a little bit, but they don't drop a huge amount compared to the day side because the atmosphere keeps us warm. Mars doesn't have a thick atmosphere, so the difference between day and night can be quite substantial. It might be, for instance, that the daytime temperature is a little bit above freezing. During Martian summer, it might be the daytime temperature could reach a rather nice 20 Celsius. But the nighttime temperatures can drop to well below minus 100 Celsius. And the rovers have to use their solar panels to charge the batteries such that at night they can run heaters to keep the rovers warm. If rovers freeze, if electronics freeze at the level of minus 100 degrees or thereabouts, then they die, in the sense that even when they next warm up again next summer, they don't pop back into life. Essentially, delicate electronics has to be kept above a certain minimum temperature. So you need those solar panels. And that ultimately is what killed Opportunity. It landed in 2004, and it wasn't until 2018 that it finally died because it was caught in a dust storm which produced so much dust in the Martian atmosphere, it effectively couldn't see the sun. And therefore it couldn't recharge its batteries. Therefore, the next night, when the temperature plummeted, it didn't have enough power to keep itself warm. The last transmission from Opportunity in our summer in June of 2018, the last transmission from Opportunity, it knew it was in trouble, it couldn't charge its batteries, and nighttime was approaching. So the last transmission was battery low, getting dark, and that was the last we heard of Opportunity. So it must have died that night. NASA said, okay, we want to send more rovers to Mars. Can we get around this problem of solar panels getting covered with dust? Well, there is one way of doing it. Well, there were multiple ways of doing it, but one verdict that they came to was, well, I think the best thing to do is we don't use solar panels as the power source. We use a thermoelectric generator. And these can provide power, regardless of whether it's sunny or not. These can provide power for many years, actually many decades. They're rather expensive. You don't use them if you don't need them, but they are great ways of powering scientific equipment for long periods of time, especially when you don't have the sunlight. So on entry to Mars, Perseverance was similar to Opportunity. In other words, it aero-braked and then parachuted in, but the landing was a little different. So let's see Perseverance, very similar to Opportunity. Let's see how they got to Mars. Again, you come into the atmosphere to slow down. So Perseverance is inside there, getting rattled about a bit, inside its protective shell. Eventually, it's going slowly enough, it can start to steer itself with little jets to make sure it's heading in the right direction. And when it's going slow enough, out comes the parachute to slow it down. But then, how do we get it on the surface? This is much heavier than Opportunity. You eject the heat shield, and then you drop Perseverance. So you use some rockets to slow it down, but you don't want to touch down onto the surface with those rockets because they would kick up so much dust, you would end up with a rover covered in dust even before you started. So they could steer it where they wanted it. They decided the rover itself was looking down with downward pointing cameras, navigating to where it wanted to be. And when it got close, it hovered over the landing site and then winched the rover down on cables. So the jets were kept above the ground, the cables were guillotined, and the crane flew away to crash some distance away, leaving Perseverance on the Martian surface. Notice no solar panels. It's got a thermoelectric generator out of the back there, but no solar panels like the earlier Spirit and Opportunity. This particular piece of CGI that showed how it landed, this long, slow pullback, reminds you that even though there might have been half a dozen rovers on Mars, that's not much if you're exploring a planet. These rovers can't go that far. They might explore many kilometers or many tens of kilometers, but that's not much. Mars is smaller than Earth by a factor of 2 in terms of its diameter, but there's an awful lot of planet to explore. So that's just a reminder that we really could do with a few more rovers out there. This is Perseverance, or Percy to his friends, and the little helicopter is called Ingenuity, or Ginny to his friends. And in this particular case, it looks like Perseverance keeps looking down at Ginny. It's like a worried parent looking down at the toddler, making sure they're still there and not running off. How is it that you get a selfie like this? Because there's nothing else on the surface of Mars that could possibly take this photograph. So how do you take a selfie? Well, in the case of Perseverance, it's not a question of holding up a phone and smiling and going click, but you have got a camera on the end of a robot arm, and you effectively generate a mosaic of lots of individual images, which you then make into a selfie. The robot arm has got a camera. Notice the lens stays still regardless of where the camera is pointing, and the camera moves in such a way that it can then image all of the rover itself, and if necessary, you simply remove the robot arm from the picture, so you're left then with a rather nice selfie. So If we again think about this particular pairing of Percy and Ginny, where did Ginny come from? We've just seen how Percy landed. Ginny was actually on the underbelly of Percy. So it was actually, here we see, of course, the view from below. There's Ingenuity helicopter. There it comes down, it's deployed and its legs comes down. Once the helicopter is sitting on the surface, Perseverance can trundle its way off and reveal the helicopter to allow it to fly. Why have a helicopter on Mars? Well, in a sense, just to see if you can. This is the first world we've visited that's got an atmosphere in terms of we've sent Apollo astronauts to the moon, but that's airless. Here we have a very thin atmosphere, but it's still thick enough for a helicopter to fly. Or it was on paper. Here we're answering the question, well, will it fly in reality? There's Ingenuity in the bottom left-hand corner, and Perseverance recorded the flight of the helicopter to see if this idea of flying on another planet would actually work. Perhaps you can hear in the background a little bit of wind noise and also a hum. That hum is the sound of the rotor blades. So you're listening to a spacecraft flying on another planet. Ingenuity made a few flights. The idea of having a helicopter in this sort of situation is if your rover moves relatively slowly and you're not quite sure what's over the next rise or behind the next rock, a helicopter can be a scouting device, if you like. It can look over the horizon and look ahead to where the rover wants to go, and it can advise the rover, you really ought to go to the right-hand side of this hill, not to the left-hand side of this hill, because the terrain looks less rocky. The idea of having a scouting device, a scouting vehicle, is one that appeals to NASA and indeed to other space agencies. So much so, they've thought, do we want a helicopter on the moon of Saturn? Titan has got a very thick atmosphere. We've sent a spacecraft into the atmosphere of Titan and it landed, but all it did was effectively photograph what it looked like on the way down. Titan is interesting because it has mountains and lakes and cloud and rain. Much like Manchester, basically. But it's definitely worth going to. Most of it is rather inhospitable. You know, it's got a methane atmosphere rather than a nice oxygen-nitrogen atmosphere. But the idea of something like Ingenuity on Mars being a test case for can we actually get helicopters to work in other places? Dragonfly would be a larger helicopter than Ingenuity, much denser atmosphere. Therefore, you can lift much more scientific equipment and fly with a much heavier vehicle than you possibly could on the surface of Mars. NASA are always interested in engaging people whenever they have any mission. And in order to get the public on board with the idea of, well, governments are going to pay for this mission, but of course, where do governments get their money from? From taxpayers. And if they wanted to get the taxpayers on board, NASA had this idea that we'll give out boarding passes for anybody that's interested. So quite a few years back, before Perseverance landed on Mars, I asked NASA for a boarding pass and they said, yep, no problem. You can have a boarding pass along with, I don't know how many thousands of other people. And what they do with all of these boarding passes, all of these names that they collect for a year or two before the mission, is they put all the names of these people on a small chip, and that little bit of white there is the back end of Perseverance. So all of these boarding passes are on board the rover. So that means when Perseverance goes exploring Mars, I know my name is going with it. It's as if I'm joining Perseverance in the whole exploration of another planet. It costs me nothing, and it costs NASA nothing. What have they done? They've added 1 milligram to the mass of the rover in order to get people engaged with the whole idea of exploring other worlds. It's an interesting way of getting people, as it were, on board. But you can still ask the question, well, why do we bother? Why do we want to explore Mars? There's a number of different answers to that. You could say we want to explore Mars because it's part of our solar system. It has its own climate, its own geology. Perhaps geology isn't the word we should use because geo means Earth, but you know what I mean. Looking at the rocks, looking at the climate, we think that Mars behaved in the past in a similar way that Earth is going to behave in the future. We have got a magnetic field and we have got an atmosphere. We believe that Mars used to have a magnetic field and used to have an atmosphere. It lost its magnetic field, which protected it against a lot of particles from the sun and elsewhere, and as a result, its atmosphere was stripped away. So in a sense, what has already happened to Mars may happen to us in the long, long distance future. So it's not just a question of looking at other planets, we also might learn a little bit more about our own Earth. And one of the really big questions is, does life exist now? Doesn't look very likely, but it's still possible. And did life exist in the past? We know water is around. We know there's evidence that water has flowed. We think the water is still there. If that water is still there, then it might be that there is life. Probably not very complex life, but maybe there is still life in the water. Some people say we want to explore Mars because we want to prepare with robots the way forward for human exploration. Certain individuals who shall remain nameless have this idea that yes, we can send a mission out to Mars and we can get astronauts on Mars in a few years. Doesn't seem very likely, it's possible, but of course it would be very expensive. So do the taxpayers of the world have enough resolve to want to send a mission to Mars with live astronauts rather than simply robots, as we have been doing up till now? In order to get a better understanding of what's going on, Perseverance has been taking samples. It's got some scientific equipment on board to analyze the rocks it's looking at. It can drill into a rock and do some chemical analysis of what elements are present in this rock. It's also storing a few samples. It puts samples in little ampules, and as well as keeping some of those samples on board, it's also leaving a sort of breadcrumb trail of samples as it goes along. Now, collecting rock samples and atmosphere samples, when we can't do very detailed analysis on board for Perseverance, well, that doesn't matter if we can get the samples back home. It'd be very nice if we can actually take those samples, return them to the Earth, and then put them through the rather more sophisticated analytical instruments that we have on Earth that we couldn't possibly fit in to a small six-wheeled rover. So we would like to get those rock samples and atmosphere samples back to Earth. But how do we do that? When Perseverance was first put up there, it was agreed that it would store the samples awaiting a mission to return the samples back to Earth. One idea was NASA and the European Space Agency would collaborate on a Mars sample return. So there's Perseverance watching a new lander come down, not a rover, but a lander. And the idea is Perseverance would then trundle up with its store of samples, and it would transfer everything that it's been doing, its little bank, its data bank of samples would then be transferred from Perseverance into this lander, and then everything would be sealed up. Okay, all you've done is transfer it from one vehicle to another. How are you going to get these samples home? Well, actually, they've been transferred into a small rocket, and that can then be launched back into orbit. There's Perseverance watching it go home. It can be launched into orbit, it can rendezvous with another spacecraft, and then those samples can be effectively sent back to Earth. That's the idea, and it's a mission called Mars Sample Return, very imaginatively, and it's been put together as an idea by NASA and the European Space Agency, ESA. Unfortunately, a certain president who shall remain nameless has decided that NASA won't contribute to that particular project. So those samples, it would appear, are going to stay on Mars. Originally, it was intended they come home for analysis. Now it looks like, well, essentially, ESA can't really afford to do it on their own without collaborating with NASA. So maybe those samples are not going to come home, or maybe they're going to sit there for decades before we figure out how to bring them back and analyze them in Earth laboratories. But in terms of the future, regardless of Spirit, Opportunity, Curiosity, Perseverance, there is a new rover on the horizon. It's called the Rosalind Franklin, and it's an ESA rover, not a NASA rover. Europe are going to put a rover on Mars. It's a relatively small thing, as you can see. It's using solar panels, not a big thermoelectric generator. It's going to be small, relatively short-lived, but it will do one thing that previous rovers have not been able to do. Because we think water is key and because we think water is below the surface, there's no evidence of water on the surface, this particular rover has got a drill. And that's what that black box there is. That will drill down 2 meters or up to 2 meters down, looking specifically for water. If it finds there is a water table down there, if we find there is liquid water below the surface, in a sense, that changes everything. Because if there's water there now, there's probably been water there for millions, if not billions of years, and the chance of life having developed there at some point in the past goes up enormously. So not only is this an ESA project, hopefully going to be launched around 2028, just a few years, you'll obviously see it, or at least it'll be well within your lifetime, and it will be operating for, well, not too sure how long. But I'm delighted to say that it's not only a European project, it's actually being built in the UK. Airbus UK are putting this together. There's a few of the people in bunny suits who are putting it together. I think it's over in Stevenage, Airbus UK. Somebody ought to tell them there's a wheel missing. There seems to be a shopping bag on the back rather than a wheel. I think they might be aware of that. But clearly it's not finished yet. It's still being put together. But the people in bunny suits seem happy about it. Give them a wave. Yeah, they seem fine. So it's only a few years before the Rosalind Franklin rover gets put on the top of a rocket and sent off to Mars to explore Mars in a similar way to other rovers, but in particular looking for water and ultimately trying to decide whether there's life on Mars or not. So if any of this has piqued your interest, you can of course find far more information if you look at the web pages of the national agencies, NASA or the European Space Agency. I haven't talked about Zhurong, the Chinese rover that's also on the surface of Mars. There's more information on that particular web page if you want to go and find out more for yourself. Thank you all very much.